Morning, guys. So we're going to again. I'll watch the time on this one, but we're going to finish off the chapter on space exploration. I did give you a tiny bit of homework, and you all obviously got it. I was really interested in this. I had just never thought about it, so that's why I asked you to look it up in case anyone else was interested too. Um, So, why do astronauts wear white suits for spacewalks? So, it's about reflecting heat. Okay, so light colours reflect heat and light, and dark colours absorb. So, the lighter colour is to reflect heat and keep the astronaut cool while they work. So, pretty much everybody who did the homework got that. Thought it was an interesting little bit of information. Okay, so we did the benefits of space exploration the other day, so we're just going to talk through some of the hazards. So I suppose the main hazard is the really, really obvious one that going into space is a really dangerous thing to do, and something could go wrong with the spacecraft, and you are many, many, many miles from home with, you know, you have to be equipped to kind of save yourself, I suppose. There's nothing anyone like. I mean, obviously you have contact with Earth, and people can offer suggestions, but you still have to kind of, if something goes wrong, fix it yourself. And obviously these astronauts and cosmonauts are really, really highly trained, but still, if something goes wrong, it goes wrong, and the odds are it's not going to end well. So there have been quite a few disasters, really, with space travel. So Apollo 1 in 1967, all three astronauts that were intended to go on this mission were killed actually in a pre-launch test. So when I say you're many, many miles from home, they actually weren't. But a fire broke out in the cockpit and they all died. Apollo 13, I don't know if anybody has seen the movie. If you haven't, you should. It's brilliant. But they had an oxygen tank explode on the command module of the spacecraft, and the astronauts couldn't land on the moon. That was kind of established fairly early on, that they weren't going to be able to. I mean, they could land, but they wouldn't be able to take off again. And they did return home safely. It was fine, but it was pretty tough. And the movie is brilliant. If you're bored this weekend and you want to watch it, and you haven't seen it already, do look it up. But that was one where they did actually all come back safe. But it really gives you an insight into how alone they are up there when they have problems. I mean, you can see the people in NASA working so hard to try to offer solutions to the problems that they're facing, but ultimately they're the ones facing it, and they're the ones who will live or die by the actions that they take. So it's a great movie. And the Challenger space shuttle in 1986, that exploded right after takeoff, or liftoff, I should say. And all 7 crew members were killed. There's footage of that. You can see footage of that. Literally just after liftoff, it exploded. And then much more recently, the Columbia space shuttle in 2003. Re-entry is quite I suppose there's several points throughout a space flight that's particularly dangerous. I mean, like I said, the whole thing is pretty dangerous, but there's several points that are particularly dangerous, and re-entry is one of them. Okay, that's where you re-enter the Earth's atmosphere. So because you're going from a vacuum into now atmosphere, so you're breaking through air, there's a lot of heat, and it can cause the shuttle to break apart. There's a lot of forces acting on it, a lot of heat building up, and it is dangerous. And they do have heat shields, to attempt to protect it. But obviously, if something fails, it fails, and that's what happened on the Columbia space shuttle. Okay, so when you talk about a hazard, I think it's the most obvious hazard, that literally space travel is dangerous. Some of the other ones I don't know if you're aware of. So they obviously risk their lives when they go into space. It is dangerous. But there are also risks to just their bodies from being in space. So our bodies are designed to work at the gravity that we have here on Earth, which is 9.8 meters per second squared. So if you want to lift up a pen or a pencil, or my calculator's here beside me, or anything, anything, there's a certain amount of force you have to exert to counteract gravity. And because our gravity is 9.8, that, like I said, takes a certain amount of force, and as a result, you're flexing your muscles, you're using your muscles, you're using your skeleton, your skeletal system, and your heart is pumping to do that job, and that's what we're used to. So then, when the astronauts go into space at all, okay, so I have the ISS there, that's the International Space Station. So astronauts go to the International Space Station, and the gravity there is about 90% of Earth's gravity. So I mean, it's there's still gravity, but it's, it's reduced, and as a result, everything you do in terms of like picking things up is easier. Okay, because there's less force acting downwards on it. So you try to pick up a cup of tea on Earth and pick up a cup of tea on the International Space Station, it's going to feel much lighter on the International Space Station, which doesn't seem like it's a big deal, but it is. Because what happens is you're not working your muscles hard enough. You're not working your skeletal system hard enough. And as a result, it starts to degrade. It starts to reduce. I mean, I don't know whether it's movies or in real life, but if you see a person who has lost the use of their legs, especially if it's somebody who had a horrific accident, but if you see the muscle wastage on their legs, simply by not walking, by not using them, the muscles just start to waste away. And it is like that, obviously not quite as severe, but it's like that when you go into space. When the gravity isn't there for you to fight against, your muscles and your skeleton just doesn't have to work as hard. And as a result, you get that degradation. You get muscles that just waste away, and your bone density reduces. There's a line there that according to scientists, space is not an environment that we are evolved to survive in. A lot of kind of what they do in NASA is like look to Mars to see, could we survive there? Could we live there? At the moment, the answer is no, because the effect on your body from spending even a limited amount of time in a lower gravity setting is quite bad. There's a couple of pictures there which are nice to look at. So it goes through some of the effects here. I've talked about some of these already. So there's effect on the bones. When astronauts are floating around in space, they are not using their bones in the same way that they would on Earth. The astronauts can suffer from bone loss in space. So they have to do exercise. You can see the astronaut there kind of attached to a machine. So they obviously can't, it's not easy to do a squat in space because, you are floating around and you're in that zero gravity environment. So they do have special equipment and they have to do it to ensure, or not to ensure that it doesn't happen, but to try and minimize how much of this bone density decrease happens. The bone loss will begin to occur only 1 week after being in space. It occurs when the rate at which the bone is absorbed into the blood is greater than the rate at which the bone is being produced. And as a result, the bone becomes weaker. I went a couple of years ago, in my previous school, I went to a talk in DCU from an astronaut who had spent 6 months on the International Space Station. And he said when he came home, he was just like throwing around, he was American, he was throwing around a baseball in his back garden with his son. And you know the way they have like kind of the catcher's mitt thing, and they threw the son, who was only like 6 or something, threw the ball, and he caught it in his hand, and he actually fractured like 5 bones in his hand. But it was because of this. It was because he had just come back from the International Space Station, and he was suffering from a weakness in his bones, and he like shattered his hand catching a ball. It was interesting. Not great for him. Interesting to hear though. Muscle, like I said, that the muscles in the body will shrink in space, leaving the body weaker than when the astronaut returns to Earth, and it's simply just because it doesn't have to work as hard. The immune system, long missions can cause the immune system to be less effective at doing its job, which is fighting off infections. The circulatory system, so that's your heart and your blood moving around, and so the kind of next two are connected. So according to scientists that work at NASA and also astronauts that have been in space, being in space is like standing on your head. So the blood collects in the upper part, so you have issues with blood pressure. And then the heart being a muscle, the reason the heart stays strong, so people who push their heart, this is why we're encouraged to exercise all the time, because when you exercise, you get your heart rate up. That means your heart's beating harder and working harder. Like people who run marathons and things like that, they work their heart really, really hard. And all of that is good for your heart because it's a muscle. So the more you work it, the stronger it gets. Obviously within reason, but generally speaking, the harder you work a muscle, the stronger that muscle gets. And when you go to space, to a reduced gravity environment, your heart just doesn't work as hard. And it feels like, oh, that's a good thing, but it's really, really not, because your heart must continue to work hard in order for it to stay healthy. It can be incredibly dangerous if you have a heart that it's called heart function, and if your heart function starts to decrease because it's just not been pushed hard enough, then you're literally, what you're emulating, I suppose, by being in space is the person on Earth who doesn't do any exercise or leads quite a stationary life. Is it sedentary? Is that the word? Spends a lot of time in front of a telly, a lot of time in front of a computer screen, doesn't have a lot of physical activity, even movement. You're kind of emulating that in space. You're just not pushing your heart hard enough. Sleep patterns. So it's more. This is more of a kind of short to middle term issue, and they have problems, especially on the International Space Station when they're up there, because it's really, really difficult to sleep. There isn't really downtime. This wouldn't be just because of it's in space. It'd be like anybody, like people who work on like these oil tankers out at sea and stuff, and they go and they work there for 3 months solid, and then they come home and they have 3 months off. Like when they work that 3 months, they're almost working all the time. So they get a rest when they get a rest, and that's not ideal. Our body really struggles to function like that. The more consistent your sleep patterns are, the better you sleep. And radiation, so this is a huge problem, and it has led to astronauts in later life developing cancer. It's one of the greatest dangers, really, that they experience when they're up there. It comes from cosmic rays that are just present in space, and because they're up there, they're experiencing them a lot more than they would on Earth. I just liked this picture. So these are a couple of astronauts who've just returned from the International Space Station. Normally, astronauts who go to the International Space Station, it's a 6-month stay, and this is them having just come back to Earth, and they can't actually stand up because the gravity is too heavy. They're just not able to stand up, which is a bit crazy. So that's all the hazards, and I think that's probably long enough. So I might leave the future of space exploration until our live class on Thursday. It'll only take us like 10 minutes less, I'd say, to go through that. Okay, so like I said on last Thursday, you don't need to take down every bit of this. You need an overview of a few benefits of space travel and a few hazards of space travel, so that you'd be able to answer a question, something along the lines of, like give 2 benefits of space travel, give 2 hazards of space travel. Something like that. Okay? So that's it. Like, you need to take down your notes. Like I said, not every single bit of notes needs to be taken down, but make sure you get a couple of hazards and a couple of benefits that you can, I say, learn off. You probably don't need to learn them off. You probably knew a lot of these anyway. Okay, so we'll leave it at that then, and then when I chat to you on Thursday, we'll finish this. We'll finish this chapter off. There's no homework. I can't really find a specific question on this, and even if I could, I'd have to wait till Thursday. So we'll leave it at that. Okay, so I will see you Thursday. Bye.